Let's talk about the future, not just gadgets, but the energy that powers everything. For decades, energy debates have been about trade-offs. Fossil fuels pollute, renewables are inconsistent. But what if we could harness the power of the sun, right here on Earth? Fusion energy has always seemed like science fiction, always 30 years away. But now, startups are racing to make it real, not just in government labs, but in warehouses and garages. These companies have real hardware, real funding, and a real shot at limitless clean energy. Today we'll dive into 5 key players aiming to build the world's first commercial fusion power plant. This isn't just theory anymore, this is the most exciting energy story of our time. Forget fossil fuels, the fusion revolution is here. Let's get into it. First up, Helion. Backed by big names like Sam Altman, Helion is taking a radically different path. Instead of the classic donut-shaped reactors, they use a linear design called field-reversed configuration. They accelerate plasma rings from both ends, smashing them together at 1,000,000 miles per hour to reach fusion temperatures. The real twist? Helion skips steam turbines and directly converts plasma energy into electricity, potentially making fusion plants cheaper and simpler. Their latest prototypes, Polaris and Trenta, aim to prove they can generate more electricity than they use, the holy grail of energy. Helion's fuel choice is bold deuterium and helium-3, avoiding the radioactive tritium most others use. Their reactor is designed to make its own helium-3, solving a huge supply problem. They've even signed a deal to supply fusion power to Microsoft by 2028, an ambitious target. Helion's approach is fast, modular, and product-focused, aiming for distributed smaller power plants. It's a high-risk, high-reward bet, but if it works, it could change everything. They're not just proving fusion is possible, they're proving it can be a real product. The world is watching to see if they can deliver. Helion represents a new wave startups moving fast, iterating hardware and aiming for commercial reality. Their vision? Clean, limitless energy, everywhere. It's a bold future, and Helion is racing to get there first. The fusion race is on. Helion is one to watch. Next, Commonwealth Fusion Systems, CFS, spun out of MIT. CFS is betting on the proven tokamak design, but with a breakthrough high-temperature superconducting magnets. These magnets are game changers, smaller, stronger, and more efficient than anything before. In 2021, CFS and MIT built a magnet strong enough to levitate a car, allowing them to shrink the reactor size dramatically. Their demo plant Spark aims to be the first to create a burning plasma that produces more energy than it consumes. Construction is underway, with a target to turn on by 2025. After Spark comes Arc, a commercial plant designed to power a small city. CFS's vision: make fusion plants smaller, cheaper, and fast to build, moving from mega projects to factory-built reactors. Their approach is conservative in physics but bold in engineering and manufacturing. Backed by major energy investors, CFS is a powerhouse pushing tokamak fusion toward reality. While Helion bets on new physics, CFS bets on new materials. Both are racing to make fusion practical, but CFS's MIT pedigree and industrial scale make them a formidable contender. The fusion field is no longer just science, it's a race to market. CFS is leading the charge for tokamak fusion. The world is watching their next move. If they succeed, fusion could go from dream to global industry. The stakes couldn't be higher. CFS is all in. Now, TE Technologies. Fusion veterans since 1998. Their goal? The cleanest fusion fuel, hydrogen and boron. This reaction produces almost no neutrons, meaning no radioactive waste and direct electricity conversion. The catch? It needs temperatures in the billions of degrees, far harder than other fuels. TE's approach is patient step-by-step machines, each pushing plasma hotter and more stable. Their current machine, Norman, has hit over 75 million degrees and stable plasmas. Next up, Copernicus, aiming for 100 million degrees and a bridge to hydrogen-boron fusion. TE's story is one of persistence, quietly raising over $1 billion and spinning off tech for cancer therapy along the way. They're not just chasing fusion, they're building a plasma science powerhouse. Their vision, a reactor with no radioactive waste, abundant fuel, and direct electricity. It's the ultimate clean energy dream. The path is long, but TE is in it for the finish. If they crack hydrogen boron, it could be the cleanest energy source ever. TE is playing the long game, and it might just pay off. What if fusion could be achieved with brute force and clever engineering? That's General Fusion's bet, a Canadian company using magnetized target fusion. Picture a sphere of swirling molten metal with plasma injected into the center. Hundreds of pistons fire at once, collapsing the metal and compressing the plasma to fusion conditions. The liquid metal absorbs energy, breathes fuel, and protects the reactor walls. It's a fusion machine built on industrial tech, pistons, pumps, and liquid metals. Their fusion demonstration plant near London will combine all these elements for the first time. The goal: reach fusion temperatures by 2025 and show net energy gain. General Fusion's approach is grounded in practical engineering, not just physics. They've attracted major partners and investors, including Jeff Bezos. If their mechanical approach works, fusion could be built with off-the-shelf tech. It's a bold, industrial vision for fusion's future. General Fusion is betting on mechanics over magnets. Finally, First Light Fusion, a wild, out-of-the-box approach from Oxford. Inspired by the pistol shrimp, they use a hypervelocity projectile to trigger fusion. Their secret: a tiny, complex target pellet, hit by a projectile at 6.5 kilometers per second. The impact creates a shockwave, collapsing the fuel and sparking fusion in nanoseconds. It's inertial confinement fusion, but with a gas gun instead of lasers. The beauty? Simplicity and low cost. No giant magnets or lasers, just clever design and fast projectiles. In 2022, they achieved fusion. Proof their method works. Next, Machine 4, using electromagnetic launchers to reach even higher speeds and energy gain. If they perfect their targets, they could build the simplest, cheapest fusion plants. It's high-risk, high-reward innovation. First Light is betting on design over brute force. If it works, it could disrupt everything. Fusion's future might just be a well-aimed shot. 5 companies, 5 radical approaches, all racing for clean, limitless fusion energy. This isn't a zero-sum game. Breakthroughs in one can help all. For the first time, the question isn't if, but when and who gets there first. The next decade will see demo plants, record-breaking milestones, and someone achieving net energy. This is more than a tech story, it's the foundation for a new future. Clean, abundant energy could solve problems we haven't even imagined. The fusion revolution is no longer a distant dream, it's happening now. Labs and factories worldwide are racing to the finish line. The world is watching, and the energy future is about to change forever.